Alright, welcome back guys. This is 1997, starting with number 19. 19 is really kind of tricky. Now, if you ignore the absolute value sign and you just kind of just do the derivative without thinking about the restrictions between -1 and 1, you're actually going to get the right answer. Now, what I'm talking about, which is kind of nice, I guess, kind of weird that they put the problem like this, although this was 1997 before you were born. But so let's say you just went ahead and said, okay, f of x equals natural log absolute value x squared minus 1. I'm going to ignore the absolute value. Just take the derivative straight up. Natural log derivative, you got 1 over the inside times the derivative of the inside. You get 2x over x squared minus 1. Look at the answers. Oh, cool. Answer D, you're actually going to get it right because it is letter D. Okay? Now, the problem with this problem is that absolute value symbol. And you're looking at other choices and you're thinking about, whoa, A, B, and C has absolute value included. In fact, B, if you look at B, that's exactly like D, except the absolute value is on the bottom. And if you look at A, the entire thing is absolute value. And if you look at C, oh, the X part is absolute value. E is the only one was like, wait a minute, that's even the incorrect derivative formula. So I hope that you can actually eliminate E right off the bat. It's not going to be E. And if you think about the graph of this, and it is a bit challenging, but let's start off with the graph of just natural log, of just a natural log graph, right? If I'm thinking about a natural log graph, I have something like this. The parent graph of a natural log, a logarithmic function, is just a curve. Great, no problem. And then you think about, well, what about the x squared minus 1 part of this graph, right? And I'm not including my absolute value, not yet, right? But if you think about x squared minus 1, oh, that means I could input negative values and put it into here because x squared makes it positive. Okay, great. And you take the natural log of positive, you are going to get answers. Which means, and you can do a table and figure this out, but natural log of x squared minus 1 does include this part on the left now. Okay? Now I am going to stop this here from -1 to 1 because we haven't examined what happens between -1 and 1, right? Because I haven't thought about that because I will get negative values of input there. Now, if this was just like this, if it was f of x equals natural log of, and I'm going to put parentheses here, just parentheses, well then nothing exists between -1 and 1. You can't put in -1 and 1 because you'll get a negative value, and you can't take natural log of a negative value, right? So that means my graph looks exactly like that. But it's absolute value, okay? So let's not think about the absolute value part yet. Let's just think about, this is what my graph looks like. I know for sure, disregarding the values between -1 and 1. Now, if this is true, let's go ahead and examine the answer choices. Now, A would be the easiest one to look at right away. A is an absolute value, and they're telling me, hey, f prime of x would give me this. Doesn't that mean all the slopes are positive because it's an absolute value? You can't have a negative slope in my answer, right? But we've already discussed that, hey, this is my graph that I know so far. And in this region here, I have all negative slopes, which means this cannot be an answer choice. They're giving me all positive values. And if you examine letter choice C, same deal, right? It doesn't matter whatever values you input here, right? You're going to get positive slopes. Don't think about -1 and 1, right? But clearly, we discussed this already, the graph here, there's a negative slopes in all the way here from the left of -1, which means C cannot be a choice because this gives me all positive values, not between -1 and 1. Okay, so automatically we eliminate A, C, and E. Now the only choice left is obviously D, the correct one, which pretend we don't know, and then choice B. Now this becomes now a 50-50 chance, right? Because if you don't know what the actual graph looks like, and I'm going to now input the absolute value here, right? And in fact, let me go ahead and do that in blue. If you didn't know what these absolute values mean for the graph, then you're not going to be able to choose B and D. It's pretty difficult. If you did know the graph, then you're in luck. But again, it's really difficult to build a graph, especially on the time test. And this is a non-calculator question. I can't just punch it in the calculator and look at the graph and, oh, I got it, you know? Um, but just to give you a heads up, like the graph actually, because it's absolute value, then the values between -1 and 1 do work for this function. I could input it, I'll get a negative value, but it's absolute value, so it becomes positive. So yeah, I could take natural log of a positive value. The graph between -1 actually looks like this. Again, really difficult if you didn't know that. Even trying to figure out, you could substitute and write a table and figure out some values, what's going on, but that just might take too long. You might be just stuck with these two choices and make the best guess. Now, if you did understand that graph and you're looking at, oh, so this is my graph of f of x, and these, choice B and choice D, are slopes. So you have to think about what happens between the slopes. Let's choose an example. Let's let x equal to -1/2, and let's also let x equals to 1/2. And I'm talking about like right here and right here. Now it's got to match, my slopes have to match that blue curve, right? So if it was choice B, right? Remember, these are my slope choices, right? If it was choice B, then I'm looking at B right here. If I input -1, I'm going to get, okay, I get a -1 on top, and I'm going to get some positive value on the bottom, right? Because it's absolute value. And then that means I'm going to get a total negative slope at -1/2, which is not true because my slope at -1 has to be positive. So just in that first choice right away, I know it's not going to be B. Okay? But again, the percentage of people the students that can get there and actually graph this is very, very small, very minimal, right? I'm hoping at least you guys get to these two choices, and then it's going to be 50-50 chance. Okay, unfortunately, if you don't have the graph, it's going to be difficult to figure out whether there's an absolute value in the bottom or not. Okay? All right, so that's it for number 19. Okay, moving on to number 24. Here we go, and I already set up the, let me move this screen a little bit over. Okay, so the term in the front right here, 1/50, that's my b minus a divided by n. So we get 1/50. So essentially you have b to a is going to be 1. The difference is going to be 1, right? So I know difference between lower limit and upper limit is going to be 1. If you want, you can eliminate e, right? Because it says right here, 0 to 50, b minus a is not 50. I got 1, right? And I'm going to divide all this into like 50 rectangles, right? Subintervals, whatever you call it, 50 rectangles. Now, if that's the case, I'm going to say my first term, okay, is going to be 1/50. And I'm just looking at any kind of pattern that I recognize in the problem here, right? And my second term, okay, 2/50. We're adding another 1/50. My third term is going to be 3/50. I'm adding another 1/50. And my last term, x50, my 50th term, is right here, 50/50, which is just 1. Well, that's kind of nice, right? Because if my last term is 1, then that must be my upper limit. My lower limit must be then 0, because b minus a equals to 1 right here, right? And if you notice, like the other pattern right here, everything is being square rooted, which means looks like my function is square root of x, and I'm inputting my x1, and I'm adding my x2, x3, and all this stuff, right? And this is going to be now to figure out, like, well, is it a right one? a right Riemann sum or is it a left Riemann sum? This is the giveaway. The last term right there, 50 over 50. That's going all the way to the edge, which means this is a right Riemann sum. If it was a left Riemann sum, it would have been 1 minus 1 over 50, which is going to be 49 over 50, right? So if it was a left Riemann sum, then this should have said like 49 over 50, right? But it goes all the way to the end, which means a rectangle has to touch all the way at the end. That's 50 over 50. So this looks like a approximation for integration starting from 0 to 1, and f of x is going to be radical x dx. That's it, right? So you get choice what? Choice B. Alrighty. Okay, moving on to number 40, which is also question number 90. So they're asking for which of the following are the antiderivatives of f of x equals sine x cosine of x, right? So if these answer choices here, if these are the antiderivatives, well, that means I'm going to take the derivatives of those, and I should get this as my answer for my derivative, right? So we're just going to take the derivative of each of these values and see what we get. So number 1, I have f of x equals sine squared x divided by 2. So the derivative of this, this is going to be a chain rule, right? So I have 1/2, this is my constant here, I'm just moving that to the front, and then times 2, and then I have the inside to the 1 power times the derivative of the inside, which is going to be cosine of x. Simplify a little bit, I get sine of x times cosine of x. Cool, so that works, right? So this one definitely works, right? It does match sine x cosine of x. So moving on to number 2. I've got f of x equals cosine, I'm going to put that 1/2 in the front here, cosine 2 squared x, which another chain rule, so great. So my derivative is going to be 1/2 times 2. I have the inside part to 2 minus 1, there's a 1 power, times the derivative of the inside, which is actually a negative sine of x. And over here, chop chop, those cancel out. So now I have a negative sine of x, cosine of x. Nope, because of this negative sign, that doesn't match just sine of x, cosine of x. Okay, choice number 3. I got f of x equal to, okay, I'm going to put that negative 1/4 on the front, and I have a cosine of 2x. All right, so here we go. F prime of x equals, I got negative 1/4. Derivative of cosine of 2x is going to be sine of 2x. All right, times the derivative of the inside part, talking about just as 2x, times 2. Which means I get, oh wait, I made a mistake, sorry. The derivative of cosine is a negative, so I'm going to put a negative right here. Sorry about that. And if I multiply, I have 2 negatives here, I'm going to get a positive, a 2 times 1/4, that's a 1/2 sine 2x. Right, 1/2 sine 2x. Now, unfortunately, if you don't know your math analysis formulas, you're going to think like, hey, that doesn't equal to sine x 2x, or sine x cosine of x. But if you remember from math analysis, sine of 2x equals to 2 sine x cosine of x, right? So if I input this in for here, just this part right here, I'm going to bring that down here, you'll get 1/2 times 2 sine of x cosine of x, which, chop chop, hey, that is part of my answer. So this one actually works too. So it looks like choice 1 and 2 work. I'm sorry, not 1 and 2. 1 and 3, which means choice D were your correct answer. Okay, that's it. Bye for now, guys. Okay, hey guys, I'm going to add number 30 or 80 back to this video. So um, remember, this question is going to be the calculator portion, so you're going to use a calculator to solve this. Now it says f of x equals 2e to the power 4x squared. For what value of x is the slope of the line tangent equal to 3? We're trying to figure out when is the slope equal to 3. So the first thing I would do is let's find the derivative of this guy. Right? F prime of x is going to equal to 2e 4x squared times the derivative of the exponent, which is 8x. Simplifying that, you get 16x e 4x squared. Okay? And we're trying to see, well, when does this equal to 3? Right? So what you're going to do is you're going to say this right here in my calculator, this is going to be my y1. Okay? And then this right here, this is going to be my y2. Y2 equals to just 3. And then you're going to find the intersection to see when these graphs match, where these graphs match. Okay, and that's it. You're going to calculate it out. You should get, I believe, x equal to, what is it, 0.168, which is choice A. Okay, bye for now.